Now let's look at the next way. We can predict future values of y as the average of the past few observed data points. Let's dive into it some more. Here is another way to look at a time series: moving average models. These models do not take the previous y values as inputs, but rather take the previous error terms. But how do we get error terms if we don't predict? Good question. We will attempt to predict y values based on a moving average, MA. That's how we get error terms. How wrong our moving average was compared to the actual value. But there can be more than one error term. But how can we identify what number of error terms should we use? Here are two examples. The chart on the left represents a time series with one error term, and the chart on the right represents one with two error terms. Notice that there is no noticeable difference from looking at the blue lines in the chart themselves. But look closely and you will see that the green dotted lines look different. This is where the difference is noticeable, since as more y values are created by the MA process, the error terms become more impactful and changes the latter parts of the chart. This is what makes a moving average model different. Now let's look at putting it all together into one model, or what we call the ARMA model. How does a combined model look like? As we have seen previously, autoregressive AR models are those that use data from previous time points to predict the next time point. These are very similar to previous regression models, except as input, we will take some previous outcome. We must select some value p for the amount of lag we believe to be useful predicting future values. Moving average or MA models, as opposed to autoregressive or AR models, do not take the previous outputs or values as inputs, but instead take the previous error terms. We will attempt to predict the next value based on the overall average and how incorrect our previous predictions were. We must select some value q for the number of previous error terms we must consider. This is how we combine them to form what we call an ARMA model to predict future values.